Today we're going to be talking about processing resinous hemp. And our guest speaker is Dan Summa. He's the founder and CEO of AgriHemp Industries. And he's been involved with building many startups over the last 30 years and has built and been an advisor to many successful startup companies. Wow, there's a whole list of them here, which is great. How exciting, including Secas, a Starbucks compliance company, sold to Silver Sky, a Goldman Sachs-backed security company, novel and engineering information company, Readability, which is called the best new web product of 2009. So lots of wonderful contributions that Mr. Summa has made, and that's really exciting to have him as a speaker today. He's also the executive director of the U.S. Ecological Advanced Research and Conservation Hub, or the acronym being USearch, and USearch is focused on research around agricultural technologies and products derived from them. And through this, Mr. Summa got involved in the hemp and cannabis industries. And USearch has received a research permit to grow industrial hemp, and Mr. Summa consults on technology related to plant growth. It's really his vision for a vertically integrated hemp company that has resulted in assembling the pieces for AgriHemp Industries. He donates his time and resources to many charities and community organizations, and he lives on a small farm in Pennsylvania where he also grows hemp. So thank you so much for agreeing to present to us today. And I think we'll just jump into it.
Again, thank you. I would like to thank the University of Vermont for asking me to be part of this. Always loved it up in the Burlington area when I've been there. We're now down in Pennsylvania, northeast PA area, so in the northeast corner of the state. Pennsylvania, just by way of some history, before I jumped in, actually was founded around hemp. So growing hemp is actually in the state's constitution. And if you did not grow hemp back in the colonial days, you were actually assessed a tax. So a lot of background on hemp. Today's, and can everyone hear me? I hope so. Today's topic is resinous hemp processing for industrial hemp. Really, how do we get oil out of hemp is the easy way to look at it. And we'll talk a bit about that. Quick agenda from my point of view. We'll talk a bit about the history of cannabis extraction, a little bit broader. So when we're talking about cannabis extraction, we'll look at both marijuana and hemp. Back in the day, it was all the same thing. Some modern hemp extraction techniques, extraction processes, known solvents, and then laboratory safety, which is always important. Here, I'll try and, I guess I've got about 40 minutes for speaking, and then we'll try and take some questions after. So just in terms of extraction history, there are many records going back hundreds, if not thousands of years of people using cannabis tea, hash, or tinctures in ancient times. The first mention of hash dates to the year 900 in Arabia, where people used to eat it rather than smoke it. So the original edibles, if you will. Old forms of extraction were started in places like Nepal, making different forms of water hash or dry sift hash, which some people use today. There's a modern form of water extraction, and dry sift not so much these days. Fast forward several decades, if not hundreds of years, individuals began to extract cannabinoids using small pieces of PVC pipe, coffee filters, and canned or odorized cans of butane. Fast forward a few more years beyond that, and the idea of closed loop extraction came about. Somewhere around 2014, the very first live resin was extracted from fresh frozen plant material by Giddy Up and Kind Bill. We'll talk a bit about fresh material right now. Most extraction is done with dry material, the exception being CBG, and I'll mention that briefly as we move along here. Now extracted products occupy about half of the popular market products, and that's true whether you're looking at the cannabis market or the industrial hemp market. And that isn't counting, the edibles made from oil, so of different things, but it's still about a 50-50 split on the product side. We will, however, focus here on industrial hemp. There may be some references to cannabinoids or to cannabis or marijuana, only because industrial hemp and the processes are about 95% of what you know from industrial hemp will move over to the cannabis space. And I mentioned that in addition to everything else that was cited earlier, we've actually built a number of grow facilities for other people here. I'm going to focus on ethanol extraction. There are two primary forms of extraction for industrial hemp. There's ethanol extraction, and then there is CO2 extraction. We'll talk about CO2 extraction afterwards. Ethanol, however, is right now the more popular form of extraction in the hemp industry, at least in Pennsylvania. And I'll talk about some places where large CO2 extraction or extractors have been built. We'll talk a bit about some of the differences as we get into the CO2 side and then and the like. But ethanol extraction is primarily used in hemp. It's used in cannabis or marijuana just to produce crude, but for hemp, this is the primary form. A cold ethanol extraction is done at minus 41 degrees Fahrenheit. You can do a cold or a warmer ethanol extraction, but you're going to end up with a lot more fats and waxes in there for winterization process. So it's actually going to slow the process down further down the process. So, but ethanol extraction is done at minus 41 degrees Fahrenheit or colder. So we pull out lots of fats and waxes, and we'll talk a bit about that. It has a relatively quick runtime in terms of just how it's actually done, and it requires a Class 1 Division 2 or C1D2 operating requirements. Those are operating requirements for airflow in your facility. So because ethanol is highly flammable as a solvent, you need to make certain you have appropriate airflow through your facility. So in our facility, for example, we've actually created an entire room that acts as a giant hood where we are moving in fresh air from outside, bringing it down through a spark-proof ventilation system, and then pulling it back out. And that air exchange happens 7 times an hour to meet national gas codes. Very, very important when dealing with ethanol. Ethanol itself is not is highly flammable, meaning it will actually burn. You actually won't see it burning. Theoretically, if you had an ethanol fire, you could actually walk through it, not see it, walk through it, and come out on the other side severely burned, which is why you need to have these air requirements, if you will. At minus 41 degrees, which is where the ethanol is, it's in liquid form. If we do have a spill, which we don't, but if you had a spill or a drip, you would actually see liquid on the floor and you would immediately try to address it. Just in terms of the extraction process, and this really applies whether we're dealing with ethanol or CO2, it'll be a little bit different, and we'll talk a bit about that as we talk about some of the issues on the different extraction processes. But as we move through the process, and we can stop at different pieces, we have our initial extraction process, which occurs in the extraction lab, or what we call the extraction lab, which is the ethanol process. And we'll show you a machine of that there in the next slide or so. We then go to a winterization process. That winterization process removes fats and oils. We then go into a solvent recovery process where we're recovering, in the case of ethanol, the ethanol, that we've run in these two processes, and that actually gives us our crude, or our initial crude from the hemp plant. And it's very interesting. Crude, for those who haven't, for those of you who may not have seen it, is named that way because it looks like petroleum crude. Just like if we were to drill a well and get oil or petroleum from the ground, where we're dealing with dinosaurs and ancient plants, same thing is that we're getting this crude, this black, sticky, resinous substance from the plant. It very much looks like crude. It needs further refinement, really, to to be worked with. For the most part, there are certain products like capsules where people may use crude, but for the most part, it needs to go through a refinement process. That refinement process starts with a devolatilization process, where we are off gassing or letting the bucket or crude that we have, this raw crude, off gas, and any volatile compounds, ethanol, is coming out of it. That's phase one of the devolatilization process. We then run it through a process where we extract further impurities from it, which again we'll show you some additional photos of that coming up. And from there we go to a distillation process. The distillation process produces the distillate, or CBD, the honey-like process product that people are familiar with. For CBG process, it's very much the same process overall. And then from there, we go to isolation. Isolation takes the crude, or not the crude, the distillate, the CBD distillate. It's used to remove THC. It also gives us a white powder. So it's a 99.95% minimum pure CBD product for us. Just very quickly before I jump into some of the other screenshots, I had mentioned up front, the use of frozen plant material versus dried plant material. We stated that we would generally use dry plant material. In the case of CBG, to contrast it with a CBD, CBG is produced in the plant early on in the plant life. It tends to be harvested early before it converts to a CBD, or when the plant is young. Many times people will freeze that plant and we'll deal with a frozen fresh plant. There's a lot of water in that. It's a very different, it's the same process. It just takes more time and to recover the CBG oil versus the CBD oil. CBG crude is also used a lot more frequently just in products than CBD crude. So ethanol extractor, what does it look like? The ethanol extraction equipment is slightly different than a hydrocarbon or CO2 extraction equipment. We'll show you both of those as well. It's a centrifugal extraction. So we actually spin a centrifuge to actually get it. The machine off to the right, which you see there, is a setup. It's a Delta Cup 9 setup that you might see. It's a pretty typical machine in this. It has average run length times, and very little pressure is used, as well as taking a relatively small or average size footprint overall. The bottom the bottom corner of the screen, you can see one of our people, Jesse, and in the back, you'll actually see the extraction equipment. So we actually have a couple different pieces of equipment there. We actually have the extraction machine, this Delta Cup 30 machine here, or Cup 9 machine, which acts as really a giant stainless steel washing machine. It's the best way to describe it. You have, if you can see in the back or the bottom corner of the screen, the one picture, and it's be easier if we were in person, but the one picture actually has frost on top of it. That's at minus 41 degrees. That is the liquid, the ethanol being gets pumped into the second machine. That ethanol is then run through this laundry process, a centrifuge, if you will. There is a teacup or a bag with 30 pounds of in our case, of dry hemp. It's basically washed, and you end up with this green ethanol that comes out of the machine afterwards at the end of the cycle. That green ethanol then moves into the winterization process. Think of winterization, and a very easy way to think about it is removing the fats from chicken soup. If you make homemade chicken soup and you put it in the freezer, you'll generally see the fat separate, and you'll end up with that frozen layer of fat up top. The same thing happens when extracting um, uh, CBD from hemp, or the crude from the hemp. So it's the process where we remove undesirable elements that were extracted for the plant. For example, we said waxes, fats, lipids. Um, Both ethanol and CO2 extraction pull everything from the plant, including material that you don't want from the final products. Um, in ethanol, as I had mentioned just previously, we end up with a green ethanol. So you end up with a product that's is ethanol or an alcohol, and ethanol is an alcohol, and it becomes, after the initial process, as I had mentioned, a very green in color. That winterization, or in CO2 systems, I guess, you end up with a waxy crude that must be mixed with alcohol to remove to remove these fats. And that's actually one of the differences between ethanol and CO2. And I'll actually comment a bit on our experience locally here in Pennsylvania, as well as some of the experiences that we've seen with other farmers who have grown and extracted using CO2 extraction equipment. So in CO2 systems, you end up with this very waxy crude. It's different from in that it's this black crude, as we had talked about, but whereas in the ethanol system, it's a more of a syrupy type product that you can pour out. This becomes more like almost like a candle wax. It's a very difficult product to work with. You do need to mix it with alcohol. You can mix it with really any type of alcohol, but at the end of the day, if you're doing volumes of crude, where people ended up was that or farmers or extraction companies have ended up, is that they ended up having to mix it with ethanol. So for the advertising or promotion of the CO2 systems, that it's a clean system, if you will, and it does not. Unlike the ethanol systems, there are no volatiles. The only way you get to a clean crude and then a distillate ultimately is to use a alcohol of some sort. So you do have a volatile. It's a little bit of a misnomer out there in the industry there. But in the ethanol systems, you end up with this green alcohol. You take that alcohol, it gets transferred to another container, in our case, stainless steel container. It gets put into a freezer overnight and for further filtration in the morning. Off to the right, you actually see our filtration system, another piece of stainless steel equipment up there, which acts to filter out the waxes and lipids from the alcohol itself. We're left, we then, after running through this process, you end up with a clean green ethanol, which then goes into the next step of the system, which is solvent recovery. I'll talk to that momentarily, but I want to point out, and again, if I had a pointer, if this was live, but you may be able to see on this piece of equipment a small white sticker with a triangular code on it, and that's really just letting people know, and all of our equipment is labeled for safety, that ethanol is in use here, and that you should be careful when using it. So everything's meets OSHA standards for labeling and the like. So solvent recovery, Solvent recovery or for reuse is a common practice. It's actually a necessary practice, more so now than ever, because of the cost of ethanol. Ethanol is extremely expensive. You wouldn't think it. The ethanol itself is actually relatively cheap, but there is actually a 750% federal tax on it for use of it outside of pretty much the petroleum industry if you're buying gas. So it's extremely expensive. So you do need to recover it or to make to make the operations economical here. Um, excuse me here, just answering a chat. Just in terms of recovery, we use what we call an ASRS, an alcohol solvent recovery system. You see a picture of it there. It's really a giant still, if you will, in terms of how we actually recover that alcohol. Alcohol has a lower boiling point than crude, so the ethanol is boiled off, turned back into a liquid, and then recollected. We pull out at the bottom of the machine during this process the crude at the end, so we end up with our refined crude. So a lot of the solventless methods and the CO2 extraction methods actually do not recover all of their solvents, rather they evaporate them off, depending on what they're using. So that's our machine there, a fairly big piece of equipment. In terms of the process and that C1D2 designation, this is the machine that we have most concern about, given the volumes of ethanol in the machine itself. Um, Devolatilization is the first step in refining our crude. Our guys call it removing the boogers. It's removal of the remaining volatile compounds in the crude. It's also the longest portion of the process for us. The final step of the process yields a clean crude and a final waxy substance that really looks like booger. So as we like to say, and you can actually see down at the lower left-hand corner of the screen a picture of these boogers, if you will, coming out of the crude itself in the process. Here over the first step of this devolatilization process is actually just letting, as I had mentioned earlier, the crude sit. It off gases. In our case, the ethanol comes out of the buckets. It'll devolve from that, and from there we take a warmed crude and bring it into the machine you're seeing at the right-hand side of it, where we are pulling out both a clean crude, which is down at the darker of the glass flask, and then the impurities, which is the smaller flask off to the right-hand side at the bottom of that picture, which are then disposed of. The clean crude is what we then take and use to produce distillate itself. So the distillation process, people like to say it looks like honey, it smells like money. It used to be the case there. We've seen a tremendous drop in the price of CBD, so I'm not sure it's quite the case, but what you're seeing off to the right are just jars filled with CBD distillate. That distillate is honey gold in color. It acts very much like honey as well in terms of its ability, its flow rate, its texture, its pourability, or how it pours, how it moves through. It also will crystallize like honey, depending on the CBD level within it. So we extract out at a very high level of CBD, and so within an hour, once once the product begins to cool down slightly, it will begin to crystallize, and within a matter of hours, it will actually be very much crystallized. It'll be a solid mass of crystals. So the process in terms of cleaning the crude and turning it into a CBD works much in the same way as the winterization process, in that the clean crude is heated, and each compound is then separated from the crude because each has a separate boiling point. So we end up with a distillate on one side, and then we end up with a waste product, which is really, again, a black product from the crude that is disposed of. We use the use of vacuums, and we do use a vacuum, lowers the temperature, which we need to run the product at to separate it. It does that by increasing the pressure on the system to extract the CBD. CBD produced at this point is a full spectrum CBD, meaning that it has THC in it. That THC is used in many things to extract or to unlock some of the properties of the CBD. So for a lot of the CBD products out there, you have different types. You have your full spectrum, your broad spectrum, but for really a lot of the oral CBD products, to get the full benefit of the CBD, you need a little bit of THC to open up that CBD receptors in the body for it. And so you'll see the market has changed somewhat in that you've seen the tinctures and those type of products, edibles and like, looking for a full spectrum CBD. The one caveat to that may be gummies, because it's easier to dose with isolate on gummies when producing them. But a lot of the tinctures are now full spectrum versus a broad spectrum. Skincare products, however, you will see products with a broad spectrum or made with isolate. And a couple of reasons for that: you're not ingesting it. And for discolorization, you don't want your skincare products, your creams, and the like, discoloring. A distillate, just given the nature of it, will actually cause or is more likely to cause a skincare product or a cream to discolor over time than an isolate. So like I had said, distillate has a look and consistency of honey. It smells like, as we said, the price recently collapsed, so smelling like money is less of the case. So distillation techniques, distillation products is incredibly important when trying to make high purity and high potency products. Fractional distillation is the process of separating the elements into boiling points and then recollecting these elements individually. Simple distillation is used to separate two components, like in solvent recovery, where fractional or white distillation is the practice of separating multiple elements. We use a wiped film distillation ourselves within our process. It's heavily used in the production or distillation, or distillate, I should say, is used in the production of formulated products and then vape pens. So that's where you're going to use a lot of distillate for different things, tinctures, dog treats, whatever it might be. Again, the one exception has tended to be gummies, where isolate is used. Due to its high potency and low impurity level, it's easier to use formulated products, making formulated products, and the distillate is usually flavorless and odorless for ingestible products, which is why it's used there quite a bit versus crude as a comparison. Simple distillation example, just a diagram for you, just a simple water flask or process burning, creating steam, and you're getting your cold water bath, and it's dropping off the product into the flask. It's a very simple model, whereas a wiped or fractional column with packing or a bit more complex will actually use wiper blades within that column to produce a distilled product or a distilled liquid. And that is fractional distillation. Isolation is the last product. Isolation process isolates the CBD molecule. It yields a 99.95% pure CBD crystal. It requires a separate isolation chamber. You see that off to the side. You take that CBD distillate. It's combined with a solvent. In many cases, it's heptane. That is what we use. An isolate crystal is added, and the CBD then crashes out over a period of some hours. You're left with large CBD crystals, which are then broken up, and then you're left with a powder after that. It can be ground to create a powder. And that powder, these crystals very much look like, almost if you picture a large salt or amethyst crystal. We then take those personally, and we actually run them through food processors to create the powder that you have. And that powder is used in skin creams, it's used in gummies, it's used in a number of other products. And that is how one of the easier ways to remove THC. There are other means to do that, but it's probably easiest just to isolate it. So CO2 extraction, I'm going to move a lot quicker here, just given time. CO2 extraction is becoming more antiquated as the years go by. And I say that just recently here in PA, combination of clearly market factors, but also just the size of CO2. So CO2 extractors are very large in comparison. They're expensive to put in. They have generally small or capacity runs and smaller runs, in that it takes a long time to do the same amount. There were a number of large CO2 extractors built for the belief that the food industry would be moving into CBD very quickly, and it will move that way. It's just that we're waiting for FDA regulations. It pulls a very fatty and wax-filled extract, so that crude that we get is almost like a candle type thing as it hardens, almost like a candle wax. And so it becomes difficult to work with. So CO2 does need to go into winterization anyway. So extraction with ethanol is more efficient. You need that. You need to add that alcohol to it. And CO2 hates water, so live resin options are not possible. So when you're dealing with CBG, which is where the market's going as well, so you have CBD, CBG, ultimately CBD, CBN, the other alphabets, letters in the alphabet. You really can't use a live resin or a live plant with CO2. So look at a CO2 extractor. It's used in both cannabis and hemp. It has same type of chamber setup. The solvent tank is a CO2 tank. It has material columns, collection tanks. It's the least explosive, which is a big positive for CO2. So you don't need that C1D2 room to run it in. So it's less expensive there. And but it does have a large footprint. Hydrocarbon extraction is the most popular form of extraction in cannabis. And when we say cannabis, marijuana, it has C1D1 operating requirements. So it's actually run in a contained, hooded environment, HAL booth, if you will. It produces a high initial quality product, and then it can produce live resin, shatter, and the like. It retains high quantities of terpenes. You can use frozen material and the like. It's good to know that's really, when we look at extraction, it really is ethanol extraction, CO2 extraction for the industrial hemp market, and then very much, again, economics change the equation, hydrocarbon extraction for the cannabis market. Cannabis market produces a lot less versus they're not growing out in farms, they're grown in greenhouses, and they'll then use this hydrocarbon extraction to move forward. Um, you can see what a hydrocarbon extractor looks like. It has three main sections, sometimes a fourth, depending on machine tanks, a solvent tank, a material column, collection pod, filtration sieve. Solvent is moved from the solvent tank, utilizing positive pressure. The material column is soaked, very much like the ethanol extraction. Material gets soaked, it's slurry, it's transferred to the collection pot, where then the butane or propane is evaporated off and recollected for use. Again, you're going to recollect that solvent where you can. And it has an average size footprint in terms of um, what's actually extracted. So we just built a grow facility. That grow facility, our extraction room here in Pennsylvania for hemp is about 600 square feet, which is a mid-size, it's a large, small extraction facility, or to a small mid-size facility. The cannabis facility, which we built, their extraction room where the how booth is approximately the same size, with the how booth taking up most of that room, but then quarters get around in air filtration. And just give you that size example. A couple of products from the hydrocarbon extraction side, a couple pictures there. Just in terms of solvents, understanding the difference between solvents is incredibly important, not only for the efficiency of the operation, but for the safety. Safety is extremely important. Ethanol, as I had mentioned, is highly flammable. Because it is a polar solvent, it's more hydrotropic, meaning it will bind to the water-soluble components of the plant. The result, though it's a less pure, generally less potent product that needs more process. The exception to that, though, is full spectrum hemp extract, which, where you want those and you want to pull things out. So comparing that with hydrocarbon extraction, the solvent is nonpolar, meaning it binds to the more fat-soluble components of the plant, the cannabinoids and terpenes only. The result is a higher purity extract. So at one end, where we're moving a lot of material through hemp, where we've got farms with industrial hemp, we're going to use an ethanol extraction, even though it's more hydrotropic, versus cannabis or marijuana, where it's a smaller amount of material, a lot higher value, and you're going to use a hydrocarbon to get more of those cannabinoids. Hydrocarbon gases can explode, where solvents such as ethanol are only flammable, so it's not explosive. So ethanol is not explosive, which is why we're C1D2, whereas a hydrocarbon or a HAL booth or HAL room is going to be a C1D1. So a lot more stringent rules just in terms of safety around that. And lab safety is probably a crucial element for this. So when we look at resinous extraction, and when you're building a facility, when we're dealing with facilities, and when we're dealing with the plant material, most important thing we're focused on is compliance. You got to be focused on compliance. After that becomes your lab itself, and then how are you going to build that in the lab safety? You have to have both components, meaning both the call it the paperwork compliance, and then the lab safety to really stay in business. And if you're not focused on that, you're going to get in trouble, which is why we want to we always end with this, or maybe we should begin with it, but lab safety is incredibly simple and should always be followed. You have to make certain when you're building these that you're meeting national and local fire codes as well as gas codes. When we built our facility, we actually had the fire chief go through it before we built anything. We looked at gas codes and the like. So C1D2 is the environment for a ethanol hemp lab. Where you need to be spark proof. Again, hemp or ethanol is flammable. It's not explosion. It doesn't explode. If you're building a CO2 or operating in a CO2 facility, you don't have this concern. For C1D1, you need to be explosion proof. Should always wear PPE, protective equipment within the lab. We have a full-blown policy for that where we test on it. You want to have safe and compliant solvent storage. So that means, are you gassing? It's area where you're storing ethanol or like compliant. How many what qualities, quantities are you disposing of that ethanol also properly? So we actually have contract with Violi to do that and move it out. Proper solvent spill procedures, storage of the final product, uh, environmental conditions to make certain they're not conducive of vapor production. Again, moving airflow is the most critical thing. And then understanding your extraction equipment and solvents. Proper equipment and training, again, it's used, which is all required under OSHA, but also just makes sense when operating in the lab. You don't want to have a problem in your lab to get shut down for that. So extremely important when looking at resinous markets. We actually we have ran through things in about 45 minutes. We actually teach extraction just for 15 hours. So there's a lot more to it. But we'll try and answer some questions and then go from there. Hopefully everyone was able to hear most of that.
Thanks, Dan. That was great. I I thoroughly enjoyed it. It was very informational. So appreciate it again. There are a bunch of questions. Do you want me to read them off and you can answer them? They're kind of in the Q&A and in the chat box. So
Yeah, and I see the Q&A ones. You can, or I can start pulling them either way, however you'd like to work this. Why don't you go ahead?
okay, let's start in the Q&A box. So, do you think processing businesses should be regulated? And if so, what kind of restrictions would you recommend?
So the USDA has the hemp rules, a new set came out. Process each state has their own set of rules, and if you don't, if a state doesn't have a set of rules, then you just follow USDA rules. So in the state of Pennsylvania or the Commonwealth of Pennsylvania, you actually have to have a license, and you are regulated as a processor. So that may be different than state of Vermont or North Dakota or California or Colorado. So in Pennsylvania, you actually do need to be regulated as a processor. I think my 2 cents worth is I think that's important. I would go one step further, and I think the formulation side is where you need to have a lot more regulations, or people need to begin to look at. So right now, very much like the compounding business in the drug side of things, people can take different things and compound. There are a lot of people just making products, um, and I think that's sort of the wild west of things. The processing side, we know, and I think reputationally, at least in the state of Pennsylvania or the Commonwealth, um, the market has somewhat shook out in that there used to be people processing, and there probably still are, processing stuff in their garages with oil dropping down and whatever. Most of those people have gone away at this point. So I do believe that processing should be done. It should be regulated. In our state, it is.
Great. It says here full spectrum. I'm foggy on the term. Doesn't it also mean other major, minor cannabinoids and terpenes, flavonoids, etc.?
Yes, there are, you'll always have some, a little bit of terps, et cetera, in your product, but full spectrum is really either is the presence of some THC within it. That's really the big item. Yes, you will always have some terps and other things within it, but it's really about the THC. Is there a little bit of THC in that product?
All right. What happens to the THC that is removed when you make the isolate?
Yep. So that THC, when it's removed, ends up in a waste product that is then it's this black, sticky, resinous, ugly product that is then destroyed. at the end of the day, is what happens to it. That's just under regulations. There is actually no regulation around that other than DEA regulations that say you can't have more than X amount on it. But that's really what happens to that. We destroy it. And like, next question.
Um, yeah, any uses for the boogers or hemp schmaltz? If my kid was on here, he'd be just like loving these boogers. Or hemp schmaltz.
Um,
Is it just discarded? Can you
yeah,
define live resin? Anyway,
Um,
boogers.
in terms of the boogers, it's again a waste product. We haven't found a use of it for it yet. It's fairly minimal that you get out of that process. So we collect it. Right now, we haven't found a use for it. We actually, our biomass, which is another waste product. So picture all of that biomass coming in, you need also to dispose of. We are working with another group of four other companies in the college for use of that that biomass there. We haven't figured out the boogers. It's such a small quantity right now that we haven't been able to focus on it yet. Real quick on live resin. When we talk about live resin, we're really talking versus live versus dry. So we're talking about collecting resin from live frozen plant versus dry plant. It's at least how we define it. Other people may define it differently.
Okay, great. Where does Delta 8 THC fit in?
So Delta 8, Delta 8, Delta 9. Delta 8 fits in, and there's just been, again, each state has different rules. In the Commonwealth of Pennsylvania, as we like to say, it's sort of like if anyone had, and I'm going to date myself, if anyone's ever seen the movie Trading Places, Eddie Murphy says, in Philadelphia, the watch is. In Commonwealth of Pennsylvania, the Department of Agriculture basically just took the stance that Delta 8 is fine, no matter what the levels and the like. They're only concerned about Delta 9. So we very much are looking at Delta H and extraction, or the creation, if you will, of Delta H from Delta 9. It enables you to get away from the Delta 9 issues, meaning 0.3 or anything greater than 0.3. Delta 8 THC, it's not regulated right now. Some people say it has less of a psychedelic effect, which is why it's not regulated. I'll leave it at that.
Great. What is your opinion of the Vincent Corporation screw press?
So I'm not familiar with Vincent Corporation's screw press. If this is there are a number of techniques out there. We have slides where I didn't bring it up, just for a press to extract live or material from the plants. We've seen it where you're taking the live plant material, whether you're using water, another one, similar principle, where you're squeezing things out, or if you're taking two plates, another good way to envision it, and you're actually just crushing the plant and forcing that resin out. It's being used more in some of the cannabis industries. We're seeing some of that. It's becoming a bit more popular. Having looked at a couple different, three grow facilities recently, they're more on the Halbooth side. So it's sort of there, but it's not there. We've seen a number of water presses where people have attempted to do it and all have failed. The hemp train, someone just, real quick, someone just spent 2.3 million and is lucky to sell it for about 1/10 of that amount. So for the most part, within the cannabis, meaning marijuana space, it's been successful, less so in the hemp space.
Great. For the small hemp processor, using the ethanol process with a still, how can we make money? What products are in demand? Are CBD hemp oil capsules marketable? Is it profitable? since it is a lot of work on top of the flower processing?
Huge amount of work. So the market dynamics have changed. So if we go back a year ago, CBD distillate, and we'll talk about distillate. Distillate was selling for um, 7,000 a kilo. Just prior to COVID, so March of what last year, you were at $4,000 a kilo. Right now, you're at somewhere between 350 to 450 a kilo, depending on where the market is any given day. So you've had since March, since COVID, you've had a 90% drop in prices. For the farmer, roughly, and if you're taking dried biomass and you are growing uh, that plant for 1,000 pounds of dried biomass, which is roughly, you can get 1,000 pounds per acre, is rough calculation. Uh, you'll get somewhere between 20 to 30, we use 25 pounds or 25 kilos, excuse me, of CBD distillate from that 1,000 pounds grown. Some people get as high, depending on the type of, and it varies depending on the type of plant and your CBD levels on that plant that you've grown. We've seen it have extracted as high as 42 kilos per 1,000 pounds. We've extracted as low as probably about 18. It just really depends on what people are. But a rough calculation is about 25 kilos um, per per 1,000 acres grown. In terms of products, your simplest product to formulate is a terpene, which is really a oil, typically a coconut oil with a distillate in it. It's a math type of equation. Then you go from there. You still will get multiples on that at final market or at a farm stand, quite frankly, to do it. But you've got to look at costs there. It's one of the big things that it's shaken out a lot of people in the industry.
What about processing that maximizes
Terpene,
terpene retention?
good question. Also, we actually run terps, as we say. Um, terps are very expensive to buy, but relatively easy process to make. If you have raw plant material, you can, and preferably live, so live fresh plant material, you get better terpenes from it. But it's basically a simple still. So if I had my earlier screenshot, there was a simple still where you're boiling the alcohol and then you're pulling off product, typically in an extraction process. Excuse me. For terps, you're actually going to use water. So with a cold ice type thing. So actually, it's a process that anyone can do. It is non-hazardous. It is non. I wouldn't do it in a wooden barn, but certainly in a kitchen, you could actually run your own terps. It's relatively simple to do and relatively low cost. The products sell for about $350 for a single bottle of terpenes.
Great. Can you process hemp grown in Vermont? I guess that's
The
going
answer
to.
is yes, we can process hemp grown in Vermont. Most of the production we do just geographically is from Pennsylvania and then a little bit from New York, just because we're right across the border from some growing regions. We have spoken to people in Vermont. All what we require, what the state requires, is a letter and a COA, a certificate of analysis of the plant that it's not uh, above the USDA limits or the federal limits. And most states require that you have a COD showing that your THC is not above. You don't want it above that federal limit anyway on the THC side, because if you cross state lines, you've now got a federal offense, which you want to avoid with interstate commerce. But yes, we most certainly could process it. I will tell you, and this gets to different things where people have processed things, just given the reputation that we have within the state, and then just the high level equipment, et cetera. People like to know that we can make the claim in many of our products, and we do. We also formulate final products that we are Pennsylvania grown, et cetera. So we do a lot of that, but most certainly we can do that. One more question here.
Yeah. This was all about commercial processes. What about stewing hemp flour in oil for a long time?
Um, I don't have a lot of background on that. I can tell you early on, and maybe I it would show a picture also. Um, we actually took hemp plants and dried it and then put it in tea bags and um, made tea out of it. If I can see this, maybe you can see this. This is actually another tea product that's just been bottled in the state. It's a little crushed can. It actually tastes pretty good. We actually processed for them, and that product's now getting some distribution. I'm working with them just because uh, I've done a lot, and one of the things we've done was in the beverage space. So we're actually introducing them to a co-packer that is more cost competitive than what these people have done. This can of tea they're trying to sell for like $5 a can. The economics just don't work that. You'll sell some. It'll be a novelty item. It won't be uh, it won't be a product that you sell a lot of. So we're trying to help them on that front. But so I don't know about just steeping or steeping the flour to get the oil. You could get some. You're not going to extract much. It's my guess. But we have taken the plant and actually made tea out of it, and makes a very nice tasting tea. A little bit of lemongrass, a little bit of honey.
Great. There's a couple of other questions. Hopefully we can cover.
Sure.
We are at the end of our time, but can you please discuss THC to CBN conversion for THC removal? Is that possible to do on a commercial scale?
Um, yes, anything is possible. That type of conversion um, requires some mass spectrometry equipment, if I can pronounce that correctly. So a mass spectrometer. The mass spectrometer, we've looked into this. Mass spectrometer is actually um, relatively cheap to buy. The problem for the piece of equipment, the problem is the methodologies are what you now pay for. So a lot of the equipment manufacturers have gone to the Gillette model where you can buy the equipment cheap, but the software to run it or the process is extremely expensive. So we don't do it. We looked into it. We don't do it. The amount of CBN that you're going to extract is fairly low. CBN probably had some use in the pharmaceutical industry, and there are a couple other licenses floating around that people that will be it. So we haven't approached it.
Um, how long is your material washed in ethanol before you continue the process?
That's a good question. It's roughly a 35-minute runtime, if you will, in the washing machine. So it's very much like a washing machine. Literally, if you walked into a Home Depot and looked at a top loader machine, Whirlpool washing machine, it sort of looks like that, only it's stainless steel. We then take, and I'm sorry I don't have a picture of it, we then take what we call tea bag, and it literally looks like a round tea bag that zips up. It's circular, it has a couple handles in it. We pack it down to between 28 and 30 pounds, and we put it in that washing machine, and it just spins for 30, 35 minutes or thereabouts in minus 41 degree to minus 43-degree ethanol.
Great.
Um,
Well,
Go ahead. There are other.
oh, no. There was one more question. Well, people are looking for books or videos that you might recommend on extraction. We can probably, send those to Catherine if you have any suggestions, Dan, and
Um,
then she'll post them.
Yeah, we actually have my guys, which we're in support of. We actually have the PA Cannabis Club, which we'll send you a couple links to, which have a couple. We've done a couple short videos of Q&A on a couple topics that pop up, and these were questions that our guys had on the extraction process, and then we got an expert, if you will, because we work with a couple companies to answer them. It's the equipment that we use. So we're happy. We'll send those. We'll forward those links on for so they can get passed along to the group
That
further
would
from
be
there.
great.
The other thing I would mention, and this goes back to the question, where is this all going, and pricing, because prices have collapsed, as I said. We My 2 cents for where pricing is, or hopefully it'll stabilize. COVID, a lot of people just grow and thought they could jump into this and make a lot of money. Didn't think through a lot of the process. We've When we got into it, we thought through the process. We probably spent more upfront, and we ended up with drying facilities, formulation, extraction, all of that, if you will. Um, but a lot of people, um, from the farming side, I'm assuming there are at least a couple farmers on the call. We are one. When you're looking at farming, you're spending a lot of your money up front for seed, etc. Um, we are, and it's arm's length, but we also have in our facility, not in our space, but in the building which we are in, there's an extraction, a DEA extraction lab going in. And we've thought about this problem, and because you do need to test a lot, both to see that your plants are doing well as well as your compliance. So we're actually have teamed together and are saying, okay, for 1,000 acre, or for 1 acre, you've got 1,000 pounds material. You can buy it up front. You can get all of your testing up front. You can prepay it at, if you will, at a discount. It's all covered under USDA loans or other loans that people may get, and you're not getting caught at the back end. I do think prices will, while CBD will be a commodity, I think, though, that the quantities will increase significantly in use. Right now, we've seen a lot of mom and pop skincare creams. We haven't seen any big brand. So you haven't seen a Ralph Lauren CBD skincare cream. And that's because the industry hasn't gotten there in terms of all the compliance. I believe that will change in the near term. First on the skincare side, and then on the food and beverage side. For food and beverage, it's being held up just because the FDA hasn't issued regulations. I expect that'll probably come out. You're beginning to see some of that. New York State just issued a bunch of food and drug regulations, or food regulations. That'll take at least 9 months to a year to get through. But in whatever next year is, 2022, you'll probably see the very beginnings, I think, of food and beverage open up, and that in turn will cause huge demand for the product. And I think it'll change again in terms of the industry, and pricing will go up for that as well. Just to give you an idea, if you've got on the cosmetic side, probably you need not a whole lot, 20 kilos to produce it, to produce 1 ton of material for cosmetics. So it's really not a lot. It means that if you look at end products or final products, it means that you could actually support a more expensive product if you get through the regulations and the like. It's just, I think you have a lot of farmers have gotten into it, and the market, unfortunately, has been artificially minimized because of lack of clarity from the FDA. It's a good way to put it. If that clarifies, you get a lot. You're going to see huge demand. My two
Oh,
cents.
there. Well, thank you. I think that's a good wrap up. Dan, this was great. Thank you. And thanks for taking time out of your obviously really busy workload that you already have to share this information with us. We really appreciate it.